All right, we're going to be doing pages 85 and 86 today. We're going to do 2. 85's pretty short. And 86 is also pretty short. So they're both pretty short. So 85 looks like this. It should be on this one. And this one's just kind of worded really weird. So now it's my turn to talk. I know.
Go.
I'm just saying it ain't about your business. Yeah. What's going on? Just have to check that. I would say, if you get need, I have stash over there. Would you need replacement? I don't have.
Yeah, I'm going to the game. You going to the game? Who's going to the game in here? Are you going to the game?
No, I'm not going to the game.
Why?
I don't want to.
What do you have against Spike football?
I want to watch them.
I just have this, pathological need to not watch other people exercise.
Are you going to the football game?
I try really hard not to watch other people exercise.
Huh?
I'm not particularly entertained by watching other people exercise.
Oh, see, you kind of.
I mean, am I wrong?
No, you not. No, it's a sport. It's entertainment.
It's a sport, but it's also watching other people exercise.
It's like watching a movie, though.
Yeah, but I'm not. I'll come to homecoming, most likely. Depends on how exhausted I am after the full week. I will probably be there for homecoming, or at least until halftime, because I need to watch the marching band show at least once. All right, so we're going to take a look at this. This is worded kind of weird. And we're going to start thinking about our solutions. We're not going to be really doing any solving today. We're going to be writing some equations, and we're going to be thinking about what would happen to our answer if something changed. So looking at this first one, they're saying, all right, if we're given an equation that looks like x minus a. So it could be x minus 2, x minus 7, x minus something. If I take a and I make it bigger, what would happen to my x? Would it get bigger or would it get smaller? If I need this thing to equal 0. So looking at this guy. If I start with x minus a equal to 0, and it's nice and little, but then I make my a really big. I make it bigger. I still need it to equal 0. What needs to happen to my x? It's going to also get bigger. So if a gets bigger here, oh, sorry, I forgot to freeze the screen so it didn't zoom in on with me. So if my a gets bigger, my x will also get bigger. If my a got smaller, my x would get smaller. So they're really closely related here. What about for the second one? I'm going to say, the way I'd put this in words here, this would be, if a gets bigger, x does too. And we can see that one's probably the easiest to see without using numbers. You can think of it as if we had x minus 2, we could find a solution, and then if I switch that to be like x minus 7, because that makes my a bigger, it would change our answer. So we can think about these with specific numbers to help us kind of spot things, but we don't necessarily need to. But what about this second one? If a gets bigger, what needs to happen to x? Is x going to get bigger, or is it going to get smaller, or is it really not going to change? a times x equals 1. So think about if I had an a of 2. What would my x need to be if I have 2 times x equals 1? What would x be if I got to a solution? How would I get x by itself? Divide. So if I wanted to get this all the way to a solution, I'd have to divide both sides by 2, and my x would be 1/2, right? What would happen if I switched that 2 to be, I don't know, an 8? That's a lot bigger. I still need it to equal 1. What would happen to my x? What do I do to solve that? How would I get x by itself? Divide by 8. So our x would equal 1/8. So as I made my a value here bigger, what happened to my x? It got smaller. It got to be a little bitty fraction. Bitty. So as my a gets bigger, my x has to get smaller. So for this B one, which I've done all in blues, if a gets bigger, x gets smaller. So we're trying to see what happens as these numbers change. Let's take a look and see. What's going on with this third one?
Oh, so pretty much, you would have to do a times x,
Mm-hmm.
and then you would write equals a.
Uh-huh.
Yup.
Yup.
Then you do
So we could try it with numbers and see if that helps.
yeah, you can do
So what if we had something like 2x equals 2?
that's what I was about to say.
What does x equal then?
That x, that's 1.
X would be 1.
Yup.
What if I made my a much bigger? What if my a was 10?
See, now you
What would my x be then?
now you go too far.
What if I made my a bigger? X equals 1 here. I'll say, what if I made my a bigger? What if I took it all the way up to 10? 10x equals 10. It's still going to be 1. I'd still be dividing both sides by 10, and I'd get to my x equals 1. So if my a gets bigger here, what happens to my x?
So your x, it'll be replaced. Wait, what are we talking about? How is it looking?
It's okay. As my a gets bigger, so as we change the 2 to a 10, what happened to my x?
2 to a 10. Yo, x got bigger too.
Did it? 2x equals 2, we got x equals 1. 10x equals 10. What was my x? Bless you.
Did you say your x was 2? Your x was 1? Oh, if your x is...
So here, when we put a in, put a as 2,
That's fine.
and then I made my a bigger. So I just picked 10. I'm just pulling random numbers
Yeah,
here.
it's fine.
Is it?
Yes.
10 divided by 10?
10 divided by 10, like, wait. It's fine.
2 separate equations.
Oh,
There you go. It happens. I'm just trying to make sure our communication's clear.
see, you just writing too much.
To be fair, y'all have a whole page for this.
It's mental, man.
I put it all on one screen so we can talk about all these things at the same
You
time.
know, like, how, like, what do we look at that telekinesis?
Telepathy. That's what you're thinking. Telekinesis is I could, put your phone away and make it go away. Mm-hmm. Control it.
You just...
No, to be fair, I targeted the phone with the telekinesis, but
Oh, you just told me to try to make everything. I forgot. I gotta charge you 2 today.
What happened to my x's here on this one?
Alright, I'll see you.
I'll change the view. Just because in case we can't see it. If I have a number times my x equals that same number, what is the only possible value our x can be? What times the number gives us itself? 1. The only thing my x can be 1, so if I change my a, my x doesn't change. The only thing x can be is 1. So for C, the only value x can be is 1. So A is not going to change it at all. Not even a little bit. I only have one more on this page, though I do hear someone's music very loud. Start dancing. We've only got one left on this page. Let's see if we can figure out what this relationship is. If A gets bigger, what's going to happen to X?
He's wrong.
Let me think. Looking at this one. If A gets bigger, what would happen to X? So when in doubt, think about this in terms of like specific numbers. We could start with a little a, so maybe something like 2. We could have x over 2 equals 1. And what would be different if I made that number bigger? How would my x change if I made that, say, I don't know, number bigger than 2? Let's go with 5. How is my x going to change? What would my x need to be here for this to equal 1?
2.
2. What would my x need to be here for this to equal 1?
5.
5. So as my a gets bigger, what happened to my x?
It's the same.
X here was
It gets bigger.
2 and x here was 5, right? So as my a gets bigger, as that denominator gets bigger, in order for it to equal 1, I need to have that same thing on top. So this one is just saying, as our a would get bigger, so does my x. It's very much the same as part A. So if I have something like x over 10, I'm not going to expect my answer to be 0.2. If I have x over 100 equals 1, my denominator or my numerator is not going to be like 1. As the denominator is bigger, so is the numerator in order to make this be a big number. So it's kind of a weird way of thinking about stuff and a weird way of looking at things. And honestly, they love to look at things in strange ways in this curriculum. Okay, so these are weird, but it's just one of those trying to think about how things shift and change as those numbers change. Because x minus a number, we see that all the time. That's an mx plus b situation. Or when we get into those quadratics with the factoring stuff, x minus 2, x minus 3, those guys. We'll get to them eventually. Okay, so we're going to do one more page. We're going to do page 86. And we are going to write 3 equations. We are not going to solve the 3 equations. I mean, we could, but we don't need to. Huh? We gotta do these 3. That's it. That was yesterday. That was those things. We do like one of those a chapter. I think there might be one chapter where we do 2, but I don't think it's until spring. We do one of those a chapter. I know. That one's fun. It happens. That's okay. We're allowed to be frustrated. It's okay. All right. So we've got here a story problem kind of situation. And they're giving us some information, but not all of the information. And in fact, in most of these, we're going to wind up with a lot more variables than we are particularly comfortable with. And that's okay. We have here that a store is selling 2 brands of headphones. We've got a high definition and we've got a basic. They're not even telling us for prices on things. So they're telling us that we have some number of the HD headphones. We've got X HD headphones. And they're going to charge Z dollars for those headphones. We also have, let's switch up my colors here. There we go. That they are going to buy some basic headphones. They're going to say Y is the number we're getting on those. And W is the dollars for those. So in these equations down here, they're going to give us some information. We're not going to use all 4 variables, but there's going to be times when we use each of them. So this really is going to let us practice the writing of the equations part, because I know that's a place that we sometimes struggle, because it's weird and awkward and unpleasant. So we have on our first thing for letter A, the number of basic headphones the store can purchase is what we want to try and find. And they're going to spend a total of $10,000 on headphones. And they buy 110 HD headphones at $70. So the store is going to buy some HD headphones and some basic headphones. So we know in general, we're going to buy some basic headphones, and we're going to have some HD headphones. That gets up to our total. So that's kind of like a basic structure. I'm going to take the 2 things I have that combines together to make our total. So if we look at this first situation here where we've got our 110s for each, 110 HD. Yep. What pieces do we know here? What do they tell us? We got a total of 10,000. So we know for sure our total, they even say total, they're going to spend $10,000. So when we're looking to build this equation, I know whatever we wind up with is going to equal that $10,000. I would love to have a budget like that. That would be fantastic. And I genuinely do not care if you put the commas in here or not, but I know it helps us read it sometimes. How much are they spending on the HD headphones? What do we know about the HD headphones? Yep, they said up here we're going to be using like X and Z. What about down here? Because they talk about the HD headphones.
70.
They're going to spend $70 each. So that's the same thing as they said for Z was going to be. And how many are they buying? 110. What will we do with those 2 values to try and figure out how much they spend in total on those HD headphones? Multiply them. We would take our 110 headphones that we're spending $70 on, and we would multiply them together. That would be our number and our cost. So I know how much they're spending on those HD headphones. How many basic headphones are we buying? Do we know? Do we know how many basic headphones
Yes.
we want to buy?
Yep.
No.
Yep.
It's still Z and X.
Let's say what number? That would be how much money. So we're not trying to solve it. We're just going to write the equation.
Still Z and X.
It'll be an X, right? Because we don't know how many they are. So, my basic was actually Y. So I'm going to call it Y because they said that's the number of basic headphones we buy. And how much did those basic headphones cost? That's how much money we would have. How much do each of the headphones cost? We don't know. W. And yes, we could get some information. We could multiply out our 110 and our 70. We could subtract and get our Y and W by themselves-ish. We could figure that out. We still have two variables here, so we aren't even going to be able to get down to a solution. We could get to a Y equals, but we don't necessarily have to. So when we're looking at these kinds of stories, sometimes it just works like a translation, as we're going to take our sum of the two things we're buying, fill in the pieces we got, letters for anything we don't. We do not have to solve these. We don't have enough information to solve these. We could figure out how much they're going to spend on basic headphones, but I don't know how many they're going to buy because I don't know how much they cost. They don't tell us that. Part B and Part C are separate pieces. We're going to do these all as like separate equations. So this was one little store. Then we're going to go to the next kiosk at the mall that sells different headphones. And we're going to go to the next kiosk at the mall that sells even different ones. So it's the same basic vibe, but we're going to write two more equations with these pieces. So it's the same kind of stuff. It's a different, like just a different kiosk selling different headphones. So they're still going to sell basic headphones. They're still going to sell our HD headphones. It's just different ones with a different total. But they're going to give us a different set of pieces on this one. So we're asked to write an equation that we could use to find the price the store pays for HD headphones if they spend a total of $2,000 on headphones and buy 55 basic headphones for $20 each. What pieces do we have? Looking at B here. Yeah, we've got our total. We know they're going to spend a total of $2,000 on headphones. So whatever's going on, I know it's going to equal that $2,000. So this is a much smaller kiosk. Maybe this one's actually a kiosk and the last one was a physical store. What else do we know? They're buying 55 of the basic headphones for $20 each. So what am I going to do with those two values? Multiply. I'd have my 55, oh, I did the wrong color. My 55 basic headphones at $20 each. So we could find out how much they're spending on basic headphones. How many HD headphones are they buying? Of the HD ones. We don't know. What are we going to use? Yeah, I was going to say, they told us to use this one, so I'm going to go ahead and use the X. Generally, when it comes to variables, I don't usually care which ones you use. You can use a happy face and a heart for all I care. You're doing the hard part. Because they do the same thing. Doesn't matter if it's a letter or not. But since they tell us which ones to use, I'm going to go ahead and use these ones. So we know we would take our Z times our X, because I could buy one headphone for however much money I have left. I could maybe get super duper fancy ones. Maybe they're noise canceling microphones, like headphones, and I would spend my $1,000 on headphones. Would not be great. But this lets us kind of find the pieces we need to find these out. Because we would have about $900 left to spend on headphones. Maybe I just buy one really fancy set of HD headphones at $900. Maybe I buy 3 or 4 that are significantly less expensive. We just don't have the information to know how many they're going to buy. So a lot of times with these, we just are trying to find our pieces to help figure out what's going on here. See if you can write a similar equation for part C. See if you can come up with a similar equation. So this is part C right here. I'm just gonna highlight these so that I've got the same colors up here. Pink, purple, blue, green. Oh, green, blue.
Got the answer.
No, those are exactly the same things I had at the top on these ones. I just was keeping them the same because otherwise I wind up mix matching my colors. All right, what do we think? How could we put this together? We've got our total of 800. We know we've got our total of 800. So that's this guy over here. So this whole thing is going to equal 800. What else we got? They're getting 8 basic headphones.
Costs 80 each.
And they cost 80 each. And what do I do with the 8 and the 80?
It's almost 80.
We're going to multiply them. Because every headphone spends 80 bucks. Those are some bougie basic headphones. If they basics, 80 bucks, those are some bougie basic headphones. So how many HD headphones are we getting? We don't know. Some number of them. We're going to call it X. How much are those bougie expensive headphones? Oh, you don't know? They didn't tell us. Could be Z. So sometimes they're going to give us pieces that we can have on each letter. Sometimes we'll get pieces that we have to like figure a whole kind of stuff out. A lot of times we'll get things that'll be like, I buy 6 HD headphones and 12 basic headphones for this. So we might have an X and a Y. We could say I have some number of headphones for 20 bucks and some headphones for 500 bucks for a total. And so we can mix and match which pieces we're given. More often than not, we're just going to wind up with 2 letters because more than that is really gross. I mean, it happens, but it's not super duper common. More often than not, we're going to be dealing with stuff that has 1 or 2 letters in it. Occasionally more, but very rarely. Okay, so as we're continuing through this chapter, we're going to see more and more and more stories. So we're going to continue practicing this writing equations part, and a lot of times it's reading carefully and figuring out what pieces we have and what pieces we want to know. When in doubt, the question that they're asking is usually what your variable is going to be. So the price the store pays for HD headphones, that's what they wanted us to find. That's the stuff we don't know, is how much they're paying on these HD headphones. We don't even know how many they're getting. So we could find those bits out. It's not particularly pleasant, but we could do it. Okay? So next week we're going to be working a lot with more stories. Yay, everybody's favorite. And we're going to talk about car buying. We're going to talk about some sales tax. Again, we're going to do some things called literal equations, which are a little gross. And then we're going to get into some inequalities. And that's going to be about where the end of the chapter is. So our chapter test is going to be, I believe, in about a week. I don't remember what day it is. 2 weeks. Yeah. Our chapter test is in 2 weeks. So 2 weeks from today. Okay, so on the 19th is when our chapter test is. 2 weeks from today. So we've got 1 more week. I think we have 2 more homeworks. We've only had 2 this chapter, so grand total of 4 in a month. Can we do that? That's like 1 a week. It's like 1 to 2 homeworks a week. Tops. I should not have as many missing homeworks as I do. It's 1 a week, and you have time to do them in class because we still have 10 minutes left in the period. You could do them right now. No, I'm going to give you time to work on it. It grades itself, and it'll tell if you were right or wrong. And then you can try it again.
You don't go over the homework.
If you look as like it should tell you if you were right or wrong,
Yeah.
and then you can always try it again. If you got questions, I'm happy to help. Like
Does it tell me the correct